All right, this last video for this pace will be rather short, page 27 through 30. Talk about three other types of bonding. The ionic bonds we introduced a little bit earlier, and that is where an atom, like one of the metals, definitely gives up an electron and becomes, therefore, positively charged. All right? So lithium, for instance, is over on the far left of the chart. It can give off an electron, become positively charged. On the other side of the chart, the non-metals, fluorine, chlorine, bromine, they are hungry for one electron. And so if they gain that electron, they become negatively charged. And then what happens is the negatively charged atom and the positively charged atom, we call those ions now, the attractive force between positives and negatives pulls them together and they form an atom, a molecule. Now technically they're not a molecule because they tend to come together and form a crystal, a whole bunch of them together. All right, and the page kind of explains how that works with ionic bonding. Then metallic bonds talks about there on page 28 and 29 and how the electrons are just kind of a sea of electrons flowing across there, and that kind of helps hold them together. And then there's intermolecular forces. So between molecules, they can be pulled together because remember we talked about that slightly negative, slightly positive zone around a molecule, and that's because of the electrons being shared unequally within the molecule. But if a molecule has a slightly negative zone and another molecule nearby has a slightly positive zone, even though they're not ions where they're being strongly held together, they will attract each other, okay? So the positive and negative will pull towards each other and they will form these dipole forces, okay? And then hydrogen bonds are similar. They're not quite the same, but similar because a water molecule has slightly negative zones and slightly positive zones. So the slightly negative zone will be attracted to the slightly positive zone, but water has some other unique properties, and so that's what's covered here in the hydrogen bonding. And then at the bottom there it talks about London dispersion forces, and that's just explaining the fact that electrons are not just still. Electrons are whirling around, they're moving around in an atom at all times at very high speeds. And so at any given point, they could be at any given place within that molecule. And if they happen to move out, maybe it spends most of its time around this negative, this oxygen, but if it were to come out here and spend a little more time around this hydrogen for a while, all of a sudden that would change the polarity of that part of the molecule. So it's a very fluid situation, we would say. Again, it's complicated. They're just introducing it to the term. You don't have to thoroughly understand it. Just read through it, be able to answer the questions about it, do some matching with some of the definitions when you get to the upcoming checkup and self-test. I think if you read through this a couple of times and answer the questions, I think you will do fine. All right? You are almost done with this fourth pace of chemistry, 1124. It does get harder, but we'll be here to help you. We'll do this together, okay?